Alright guys, let's begin our next day, day 4, and we are starting this with very first topic which is abstraction. The question is, what is abstraction? Abstraction is a process of where we will show the functionality but hiding the complexity or hiding the implementation. That is something known as abstraction. And we can achieve or implement abstraction either by interfaces or by classes, abstract classes. Now let's try to better understand abstraction by some real world example. Abstraction is not a concept that is specific with programming only. It's a real world concept. You will see in your day to day life various places abstraction is actually implemented. For example, you have electricity board in your house where you have different switches. Okay, let's say if you are turning on some switch which just turn on electric fan, and you never know how the wiring internally installed in your house, how the electricity is flowing internally. You just have one functionality, a switchboard, a switch there, and you are accessing that functionality, and then fan will start working for you. Similarly, other electric device works for you. You never ever know how the internally the wirings and the electricity basically goes to that device and how it is internally working, right? So that is what abstraction is, showing functionality, just showing up you switchboard and then hiding the implementation completely or hiding the complexity. There is another real world example of abstraction, that is car. When you drive the car, you usually change the gears, okay, just to speed up the car or speed down the car. When you switching the gears, you never ever knows what is actually happening inside the engine, what is the mechanism internally working which is speeding up the car or speeding down the car, right? But you knows only how the gear system is working. The functionality is given to you, the implementation or complexity is hidden from you. That is again another example of abstraction. Now the question is, what is the purpose of abstraction? Abstraction is mainly used to achieve generalization. What is generalization? To better understand what is generalization, we first have to understand what is interface. Interface is a blueprint of class. Okay, why I'm saying interface is a blueprint? Because interface is quite similar as class. Whatever the characteristics are applicable on class are also applicable on interface. For example, when you define a Java class in certain file, file name and class name must be same. Similarly, when you are defining interface in some certain file, the file name and interface must be same. Another point is, for interface and class, naming conventions are same. If you are defining interface name, first letter of each word must be capital. It is the same rule as it is with class name. Next point is, as you guys know, when you compile the Java file, a class file will be created for each Java file, which contains the bytecode of that respective class. Similar to that, in interface also, when you compile interface file, it will again create a class file, and that class file will contain respective interface bytecode. So it is again the same. The last point is, both are having same program structure. For a Java class, we always have two class members. One is known as data members or class level variables, and the second is methods or member functions. Similar to that, in interface also we have two members. One is variables or data members, and the another one is methods. And both can be static or instance as similar to class. So both are having same program structure. As you guys have seen that there are many similarities between a class and an interface. Then the question is, what is the difference between them? Why we are saying that interface is just a blueprint of class? It's not actual a class. Where is the difference? The difference is interface only contain the methods which are not having the body. Only the signatures are going to be held by interface, and those type of methods which are not containing any body with it, are not containing any implementation with the method, are known as abstract methods. Okay, how you can define abstract methods? You need to use abstract keyword to define abstract methods. Those methods are only having signature. Okay, but in interfaces, by default all methods are of abstract type. That means if you will not even define abstract keyword inside the interface, just defining the method signature, that's not mandatory to mention abstract keyword there. That's fine if you are not having abstract keyword. By default, every time all the method signature will be considered as abstract methods inside interface. Let's try to better understand interface by this implementation. There are two new keywords I'm gonna use here. One is interface. Interface keyword is used to define the interface, and another one is implements. Implements keyword we always use when we inherit interface into a class. Now, there are certain rules that are always associated with interface concept. Rule number one says that all the methods declared inside the interface are by default of abstract type, which means that if you are using abstract keyword to declare any method signature, that's fine. But if you are not even using abstract keyword to declare method signature, that is by default treat as abstract. So all these methods are of abstract type. Rule number two says that you cannot create the object of any interface. Why this is the rule? Because if they allow you to create the object of interface, you will start calling the methods directly. And if you will try to call these methods, which are abstract methods, those are not going to perform any functionality because functionality is not associated with them, and in that case there is no sense to call those abstract methods directly. So to avoid this case, they create this rule that you cannot instantiate interface. Now rule number 3 says that all the methods inside the interface are by default public and abstract type. Why those are public by default? Because as you guys know that you cannot create the object of interface, that means you cannot call directly any abstract method. Okay, that means that will be only used by some implementation, by some child class. And how that will be available to child class? If that method will be of public type. And that's the reason they make all the methods inside interface by default public and abstract type. The next rule of interface says that all the data members or class level variables inside the interface are by default public, static, and final type. Why those are public? So that those will be available to all of the implementations of interface. Those are of static type, so that those will be directly accessible by using interface name. If they make them instance type, then we must have to create the object of interface first, because instance data members take place inside the object. And as you guys know, we cannot instantiate interface. That means instance data member can never take place inside the object of interface, and that's the reason they restrict that always variables will be of static type only. The third is all the variables are of final type. They are making them final so that they are making them constants. So the same values will be available to all of the implementations of interface. And sometimes there is a multi-threading environment where multiple threads can modify the same data, and then there will be a data consistency problem can be raised. To avoid that type of situation, they create them as final. You are going to understand data inconsistency in multi-threading concept, so don't worry about it as of now. And the last rule says that whenever you define the interface, you can never define constructor inside the interface. And you know that why we are not having constructor, because you cannot instantiate interface object, and that's the reason constructor will never get execute, and that's the reason they says that you cannot create the constructor inside interface. Okay, before we proceed further, let's understand one more key rule that is associated with interface, that is abstract methods must be defined either inside interfaces or inside abstract classes. You can never define abstract methods inside a normal class or concrete classes. Okay. Now let's try to understand rest of the implementation. In here, I have these abstract methods and I am defining the implementation of this media player as a music player, and in video player also I am implementing same interface. Okay. Now, as you guys know, these are the abstract methods, and when these methods comes to the normal class or concrete class, and you know that these methods are of abstract type, abstract method cannot be reside there within a normal class or concrete class. Then how we will handle these type of situation when abstract method is coming to concrete class? What we need to do is we have to override that abstract method and we have to define the body of that method. Okay, so that that method will no more abstract, and then a normal method can be defined in a concrete class. In that way, I am defining the implementation for play method, pause method, and stop method. Okay, similarly, For another implementation of media player, which is a video player, there also again I am defining all three methods implementations there. Okay, here I am instantiating both of the class objects and then I'm calling the methods of both of the objects. Let's run this and then you can see I'm getting music player methods execution first and then video player methods execution. So both implementation are executing one by one, and this is how we are using interface by implementations inside the child classes. Now in this second implementation, I have two different interfaces and both of the interfaces I am implementing in one child class at same time. Means one class can implement multiple interfaces at same time. Okay, we are just defining the functionalities inside the child class and then we are instantiating the child class and then we are running them. So it's pretty simple. Okay, with this implementation we are pretty much clear that one class can define implementations for multiple interfaces. Similar to that, there is one more rule associated with classes, that is if you want to extend your child class with some base class and implement your child class with base interface at same time simultaneously, then also you can achieve this. The only thing you need to take care is you first have to extend your class with parent class and then you will write implements with base interface. The syntax will looks something like this. You will have a class, you will extend that with the base class name and implements that with interface name. And then you can do the implementations inside smart device or child class, whatever you are having. So this is another property of a class. So class can implement multiple interfaces same time and class can extend another class and implements another interface at same time as well. There is one more interesting point here is you can also implement multiple inheritance within interfaces. For example, I have a device interface and connectivity interface and I am extending both of the interface in further another child interface which is smart electric devices. And because now this interface is extending the functionalities from the parent interfaces, that's why I'm not using implements keyword here, I'm using extends keyword. So always remember, when you are inheriting from one interface to another interface, you will always use extends keyword, and when you are inheriting interface to class, you will use implements keyword, and then rest of the implementation is same. So you can get all these implementations here in the day 4 oops 1 folder. We have these implementations, oops implementation 2 and implementation 3. Okay, and all the theory that I have covered in interfaces and abstraction you will find here. All the rules related to interfaces you will find here, and related to abstract methods also you will find here.